Hi everybody, this is Gigi from Kauai Community College. In this video, I will be talking about counting methods. Counting methods are being used to count the number of ways an event can happen, and we then use it to calculate probability. Okay, so let's get started. All right, counting methods. The first method that I'm going to go over is called the blank method. That's what I'm going to call that. But in most math books, you would see this as the fundamental counting principle. Okay, now what this said is that the number of ways in which a series of successive events that are events that occur one after another. Okay. And we can find the number of ways by multiplying the number of ways that each event can happen. For example, so this is what we also call as the multiplication principle. But in short, for this class, I would just call it the blank method, and you'll see what I mean by that. All right, so for example, if you have 5 shirts, 4 pair of pants, and 3 pair of shoes, how many different outfits can you put together with these choices? Okay, so we are going to use a blank method because these are successive events, because you're going to pick a shirt, pick a pair of pants, and then pick a pair of shoes, right? Things that happen one after another. Okay, so first pick a shirt, then you'll pick a pair of pants, then you will pick a pair of shoes. Okay, how many choices do you have for shirts? 5. 4 choices for pants and 3 choices for shoes. Now, the fundamental counting principle or the multiplication principle is that you just go ahead and multiply the number of choices for each of those events to get a total number of ways that you can put these outfits together. Okay, and 5 times 4 is 20, times 3 is 60. So you have 60 possible outfits to choose from. And I call this the blank method because, as you can see, you go blank, 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 and then you multiply, right? All right, now the next thing that I want to go over is an example that is kind of interesting for us to know here in Hawaii. My question to you is, how many possible Hawaii phone numbers are there? Now, are we going to run out of phone number if everybody have a cell phone here in Hawaii? Well, let's see. Okay. Now, let's note that 808 is the area code for the entire state, and the local extension cannot start with 0 or 1. Okay, what I mean by that would be the red first 3 digits there. The first digit right here cannot start with 0 or 1. Okay, now this calls for a blank method, right? So you're gonna go and see how many possible ways can this happen. So the first 3 digits, that's the first 3 blank, and then the last 4 blanks. Now this cannot be 0 or 1, and we are in base 10, so we have 10 digits, 10 numerals to choose from, minus the 0 or 1 that we cannot use for the first choice. So that would be 8 possible choices there. And then the rest of them will have 10 possible choices, right? Now that would be an 8 with 1, 2, 3, 4, 5, 6 zeros. And we would say that would be 8 million phone numbers in Hawaii. And we definitely don't have 8 million people here yet on island. So plenty of phone numbers for us so far. Okay. Now, The next concept I want to go over before we learn the two basic counting principles um, that are called permutation and combination. Before we do that, we need an operation called factorial, right? So we had multiply, divide, exponent, right? Addition, subtraction. Now we have factorial. What factorial is a product of the integer and all of the integers below that. Okay, for example, 4 factorial. Okay, 4 factorial, that's how you read that, is the product of 4 times 3 times 2 times 1. And that would be 24. Okay. If you had 9 factorial divided by 7 factorial, okay, that is called factorial. Then that would be on the numerator, you have 9 times 8 times 7 all the way down to 1. And then on the denominator, you would have 7 times 6 times 2 times 1, right? And we can see that 7, 6 all the way down to 1 are common factors in this fraction. So we can go ahead and reduce by dividing out those common factors. And all you have left is 9 times 8, which is 72. Okay, so factorial is the product of the integer and all of the integers below it. All right, so we are now going over permutations and combinations. Those are the two basic counting principles methods that we have, the two basic counting methods. Permutation and combinations have two aspects that are in common, two characteristics that are in common, and one that distinguish one from another, okay? So the two common characteristics are that you are going to select n items out of a group, r items out of a group of n items. That's the common characteristic number one. And common characteristic number two would be the items cannot be used more than once. Okay, so once you pick the items, you don't put it back to use again. All right. Now, what determine permutation over combination is the order. Okay, so in permutation, the order of which the R items are being arranged does matter. In combination, the order does not matter. Okay, and if it is a permutation, we would say permutation of n choose R, and that's how we would write that. Permutation of n choose R is n factorial over n minus R factorial. Okay, and in combination, we would say the combination of n choose R is n factorial over R factorial times n minus R factorial. Okay, now keywords for you to distinguish between permutation and combination. For permutations, you would see words like arrangements, scheduled, order, ways, unique, words that tells you that the order of the arrangements of these items matter. Okay, and keywords for combinations would be just choosing a group, a sample, a selection, and sometimes even say a combination of n items. And that would tell you that the order does not matter. Okay, so here are two examples so that we can see what the differences are between permutation and combination. Just FYI that permutation really um, is the blank method. So most of the time, actually, I would prefer to use the blank method rather than permutation, but it's up to you, okay? So here are your examples. So a family is planning a movie night. In one night, they will watch, in order, 3 different movies. And they own 14 movies. So they have 14 movies to choose from. So how many different ways can they watch in order 3 different movies? Now this tells you clearly that order matter. So that would be permutation, okay? And then an example like this where it said at each practice, a coach of the football team will pick 4 players to stay after for additional work. And if there are 32 players on the team, how many ways can coach pick 4 players to stay after? Now, there is nowhere in here that indicate the order of which these 4 players are being arranged would matter. So that is what we call combination. Okay, so here on the first example, you would say permutation of n choose r when n is 14 and r is 3, right? So permutation of 14 choose 3 is 14 factorial over 11 factorial. And, if you think about it, 14 factorial would be 14 all the way down. And then on the denominator, you have 11 all the way down. So from 11 down would be common factors. And you are left with 14, 13, 12. And multiply together. And that's just like the blank method, right? So as I said before, lots of the times I just use the blank method rather than permutation. Okay, now for this combination, you would say you have n of 32 to choose from, and r is 4, right? So combination of 32 choose 4 is 32 factorial divided by 4 factorial, that's r, and then n minus r would be 28 factorial. And if you write all this out, that's what you have, and you can just put that into your calculator to get a number, okay? So this lesson, the main concept would be for you to determine permutation or combination, and then permutation, if it's a permutation where order matter, then you can also choose the blank method if you like to. Okay, so constantly when you're counting in probability, constantly think, am I using permutation? Am I using combination? And then sometimes you do have to use a combination of those methods in order to count, right? All right, that is it for me today. And I will see you in the next video, I guess.